showing that they collect material.
Welcome to all those who are attending this second session of the junior program for students who are wanting to improve their problem-solving skills in mathematics in order to participate in competitions. But that's only the secondary objective. The primary objective is to give you the muscle to solve problems, mathematical problems, which are contextual. In other words, there are stories around them, and at the same time, they can be quite challenging. This is real mathematics. The meat of mathematics is in problem solving. The kind of mathematics you do in school is to only give you the tools to do mathematics, but it doesn't really help you to understand how those tools work. And here we will have the pleasure of seeing how these things work. All right. You have all been switched off so that your mics have been taken off centrally so that any noise which is coming from any one particular venue is muffled. Sometimes you have people who are talking and so on. At the same time, please don't write on my board. Yeah, sometimes people decide to write some notes on my screen, which is quite distracting. So please just bear that in mind. Try to concentrate on what we are doing. And if there are any questions, you can raise them in the chat column, and then we will try to address them at the end of the program. I will still give you a chance to ask some questions at the end if we have the time. All right, I want to also welcome my good friend David Ramaboka, who is the one of the project managers in South African Maths Foundation, and is always here ready to help whenever there is needed from the foundation, which is the body which sponsors this program. South African Maths Foundation, and I trust you know their website address. You can write this thing down if you don't know. www.samf, South African Maths Foundation, .ac.za. Now this site gives you all the possible information that you need in order to have some input into the different things that we are going to discuss in these programs. You'll have the recordings, which will only last for a week, and yeah, and any other information that the coordinators want to put on. Okay, so that's on that foundation. Okay, with those words, let's go on to the first problem that we want to discuss. And the first one that we want to discuss is something that we didn't have time for last week. And I left this problem with you and wanted you to try to see whether you can work it out. It's a very interesting problem because you've got to find the square root of some number, and that number is quite big. And you're not allowed to use calculators. That is the challenge. How do you work this thing out without using calculators? Many people will find it very difficult to believe this, but it can be done. And we're going to see the power of algebra. Okay, so as I said last week, one observation is that this number here is actually twice this number here. Okay, so a good trick very often well, not often, but it happens in these problems, where you take a number and you give it a name. And the reason is that it's easier to work with symbols than large numbers. So sometimes if you have a large number, put a symbol for it, and then try to work out everything in terms of that symbol. So now you've got, I'm calling this x, which means that this part here is 2x. And this part here is x. And this part here is also x. Right, okay. Now I want to calculate only the object inside the square root sign. And later on, there are 4 groups of 3, I see here. Right? 444,000, oh, it's billions. Okay. Minus 888. 888. I want to calculate this and then work out the square root of it, rather than carry the square root right throughout the calculation. Okay, now one must be a little bit careful here. I said that this is x and this is x. This doesn't mean this is x squared. We're not multiplying these. This is a large number which has got 12 digits in it. So how do we write this thing here in terms of x? Well, if you look at that large number, it is actually your x, which is 6 fours and 6 zeros here. And here you can add to this. So this number here is actually the sum of these two. Okay? So now this part here is x. And this part here is 1,000,000 times x, because it's this number here times 1,000,000. So this is equal to 44444 times 1,000,000 is, okay, we can put 1,000,000. This is the thing that I'm speaking about, plus 444, right? So I'm rewriting this 12-digit number and then minus twice. So now you got your x here everywhere. So you got, this is x times 1,000,000. So you can say 1,000,000 x. X times 1,000,000. And this is x. And this is minus 2x. Okay, now you see this monster is now being tamed. You've got something which is much more simpler to handle instead of having this large number. So that's the advantage of giving a name to a large number. I just want to say that x minus 2x can be simplified. Okay. And now you have 1,000,000 x minus 1x. So that has to be 999,999 times x. 1,000,000 x minus x. Otherwise, you can take out x as a common factor. And this is x times 1,000,000, and this is x times 1. So when you take out x as a common factor, you have x into 1,000,000 minus 1. And 1,000,000 minus 1 is 6 nines. Right? If you take away 1 from 1,000,000, you have 999,999. And this is times x. All right. So this thing here actually simplifies to this. And let's put our substitute for x here. And you have 444, 444. Okay, so you got the subtraction sum is now converted into a multiplication sum. That's the advantage of factorization. Factorization takes subtraction sums and addition sums, it takes them into multiplication, which is very powerful, because when you multiply, you can do all kinds of things with multiplication. See, one nice thing, like for instance, if I know 18 times 32 divided by 24 times whatever, 36, right? Well, you can cancel. 18 goes into this one time, 18 goes into this two times, 8 goes into this 3 times, 8 goes into this 4 times, 2 goes into this 2 times, and you have 1 times 2 over 3 times 1. And it simplifies very quickly, 2/3. You can only do this because you can multiply. But if you had subtraction, you can't do that. 18 minus 32 or 24 minus 36, you can't cancel. This is subtraction sum. You can only cancel if you're multiplying. So that is why that's a nice thing. So this subtraction has been converted into multiplication. Now we need to find the square root of this thing, right? So to find the square root, you need to write this, factorize this. Now this thing here, 9 goes into this. 9 times 111, 111, right? And here, this is times, because these are multiplied. 4 times 111, 111, the same thing is repeated. So now we can answer the question, because the question says, what is the square root of this number? And we can see the square root very quickly now, because it's now factorized, and then you have to take, if the numbers which are repeated, then you take only one of them. Square root of 25 is just simply 5. It's square root of 5 times 5. So when you take square roots of this quantity here, that's what I want. 9 times 4 is 36. So I'll just multiply these two. And then the other number is multiplied by itself. So we can say that is squared. So this is 6 squared times 1 squared. And the square root of that is the square root of 36, which is 6. And you take one of these, so multiply twice. So you get 6 times this, and that's an easy sum. 666, 666, which is the answer to the question. That's a very beautiful example of how you can use algebra, right, to solve a problem without having to use a calculator. Right? Too often we are subdued by calculators, and we become victims of it. So here, without having to use a calculator, we can actually solve this problem here, which looks quite difficult to solve. So like that, you can do other examples. I was going to go and look at other examples in the book. Right, the book I'm referring to is the book that I wrote. Hopefully all of you have got it, but you can search for some examples there. Like there are examples like this. 2883 times 2887 minus 2881 times 2882, something like this. Now here again, you're not allowed to use calculator. Now you can do long multiplication, and you'll get some horrible number here, and you get this, you get another horrible number. Subtract the two. There's a good chance that you'll make a lot of errors along the way. But this too can be solved by using this X method. Just call X to be one of them. Say X is 2883. Right? Then 2887. This next one is X plus 4. So like that, you'll see that this is X. Remember, this is your X times X into X plus 4 minus this thing here is x minus 2 because it's 2881. See, if the numbers are close to each other, then it must send a signal to say, oh, I can call one of these numbers x. And this one here is 2883, so it's x minus 1. Now this you can work out. Right? Your algebra tells you how to work this thing out. And when you multiply this out, I'm not going to do it in full. Remember, there is a minus sign in front of this bracket. So I can just work out the bracket thing and take the minus sign out. So you change all the signs. X squared minus x squared goes away. 4x plus 3x is 7x minus 2. So this is 7 times. Remember, now you substitute for x because this is very easy to calculate. So you simply have to multiply some big number by 7 and subtract 2 from it. And that is a very much easier way than adding all these, than multiplying by log multiplication and subtracting. So this is another example where you can use a symbol to make a calculation and then use algebra. All right, so the next problem. This is your homework problem. I've got it in red. Okay, so I think your tutors will send you this problem, or it's in your workbook. It's in your workbook. The problem, what do I call it? Problem sets or something like that. The book in which all your problems are written, right? I'm just going to quickly repeat what I said last week. There are 9 sessions, and each session has got, we will only discuss certain problems, and those problems are in that, there's a full set of problems in every one of them, but we will select only a few to discuss. The other ones, you can work it out on your own as an exercise. If you get stuck, you can call upon any one of us, right? You can send an email or send a WhatsApp or something and ask us for some hints. We won't solve the problem for you. We'll give you some hints, tell you how to do it. But these are the ones which are not done in this session. So we've chosen some problems in the session, and this is one of the problems, but I'm giving this to you as an assignment. Each week, you'll have an assignment problem. And this week, that is your assigned problem. Okay, we're not going to discuss that problem because it's something that you will do as an assignment and your tutors will mark it and they'll come back and give you the solution. All right, now let's look at the next problem. Determine the sum of all integers x which satisfy the equation this. Now you see, you've got a funny equation here. You are familiar with equations like this, 2x plus 3 equals 8. Right? So what you call a linear equation. And then to solve it, you'll put all the x's to one side and take the numbers to the other side. And you say 2x equals 5. So x is equal to 5 divided by 2. Right? You're familiar with that. And maybe some of you might be familiar with quadratic equations. I don't know whether you are familiar with this. Here too, you can solve this thing. I'm not going to go into that. But there are ways of solving that. But this is very different here because you've got an exponential. You've got an x sitting at the top. But the observation is that it's equal to 1, you see. So you've got something raised to something else, which is equal to 1. Now, there are some situations only where an exponential is equal to 1. One of the situations is where the exponent is 0. Okay? Now, any number, those of you are in grade 8 might not have come across this, but any number raised to the power of 0 is 1. See? So you have, like, for instance, 3 raised to the power of 2 is 3 times 3. 3 raised to the power of 1 is 3. But 3 raised to the power of 0 is 1. Okay? Always. Any number raised to the power of 0 is 1. So to solve for this, you can say that the exponent is 0, and that's a linear equation. Bring x to one side, and then it goes to the other side, and this is a possible value for x. A possible. It's not the only value for x. They say the question is find the sum of all the integers. Right. Now, an integer is a positive or a negative number. So this happens to be an integer. It's a negative number. So a negative natural number. Integers are counting numbers and there are negatives. So this is a counting number and it's negative. It's an integer. So this is one of the possible values for x. But now when something is raised to the power of something and you get 1, then you can say something about the base. Right? The base has to be 1. Okay, so the base 2019, if that is equal to 1, 1 raised to any power is 1. This is 1 times 1 times 1 times 1 any number of times. It doesn't change. It's extremely stubborn. It remains at 1. So you can have the base equal to 1. It doesn't really matter what that is. But if the base is 1, this exponent is 1. And in this case, I can solve for x. If you bring x to this side, you get plus x. So the 1 is brought to the other side. So it's 2019 minus 1, which is 2018. Okay. So the chances are you will say, yeah, okay, now I've got the base could be 1 or the exponent could be 1. And I have these two values, and you add these two x's and say these two here and say that that is your answer, the sum. You are asked, remember, the question is find the sum of the integers. So you look at all the solutions and you add them. Always answer the question. But the vast majority of people will miss the next one because you need not have 1 as your base. If I ask you what is minus 1 to the power of 4, you will say it's minus 1 times minus 1 times minus 1 times minus 1. And there are 4 minuses, so you'll get 1. Every 2 of them will give you a plus. So you can have the base equal to minus 1. See? That is something that you might miss. But that's provided that the index is 4. If the index was 5, then you're not going to get the answer 1. See? If the index was 5, then you can get 5 negatives, and the answer would be minus 1. So minus 1 to a power, when I say index, it's the same as exponent. Minus 1 to an exponent is equal to 1, provided that exponent is a even number. It must be an even number. Right? If it's odd, it's not equal to 1. So let's make this equal to minus 1. In which case, I'm sorry. I'm making the base equal to negative 1. And then what happens is that let's take all this stuff out. Okay, then you can solve for x in this case. If you bring x to the right-hand side, I like to bring it like that, x being to the right-hand side, then you take 2, negative 1, bring it to the left-hand side, and that gives you 2020. But we still don't know whether this is a solution, because we have to check to see whether the exponent is even. Now, if x is 2020, the exponent is 2020 plus 2020. And yes, that is even, right? You got an even number plus an even number. So it's allowed, right? This particular value of x gives you an even exponent, and that'll give me 1. So this is a solution, right? If the exponent was negative, then we can't use this x. Right? We'll have to discard it. So I can put a circle around this to say it is a solution. So what you have to do is to add up the 3 solutions, and you are required to work out the sum of all these 3 solutions. I've circled them. So we simply have to add those 3 numbers minus that plus the same thing is 0. And then when you take 0 and you add it to 2018, that gives you 2018. So the answer to this question, remember now, it's an interesting one because you move away from the obvious. You might think that this is the base is 1 always, but remember the base can be -1. It's an important fact, which I hope you will not forget. Okay. All right, so I've gone. So this is the second problem that we have done. So let's get on to the third problem. Yeah, so the answer really has got all these. It's important to, this part is part of the answer, right? Because you have to test to see whether the exponent is even, right? And if you are asked this question, if you simply put down the base as -1 and you leave it like that, then you can lose at least 2 marks. I would take out 2 marks because -1 to some power is not always 1. So you have to make sure that the exponent is even, and you must test that and check it out. Then you'll get the full marks. Okay, so now let's just get on to the next problem. Okay, the next problem is a story problem. Mary has 3 types of toys: teddy bears, cars, and jets. And then we are told that all her toys except 21 are jets. And that's a little bit difficult to understand. Okay, so it's always nice to draw a diagram. And just draw a diagram to just put all the toys together like this. And then some of them are teddy bears, and others are cars, and the other are jets. Okay, so you've got 3 types of toys. Now, all her toys except 21 are jets. In other words, all these except 21 are jets. So it means that you have to, yeah, these are the exceptions. All of them are jets except these, the others. All right. So these 2 together, they add up to 21. So let's give a name to, we don't know how many there are in each one of them. So I'm going to say that this is X, and this is Y, this is Z. Means X teddy bears, Y cars, and Z jets. All right. So our starting point should be let X equal to number of, this is a symbol for number of teddy bears. I'm not going to write that in full. You must write it in full. Y equals the number of cars, and Z equal to the number of jets. Okay, so what we said is all of them except 21 are jets. So these two together add up to 21. That is the idea. Right? With the exception of jets, the rest are 21 in number. The same thing, with the exception of teddy bears, the rest are 23 in number. So if you leave the X out, leave that. So these two, Y plus Z equals 23. And then the same way, all of them are cars except the other two, which is X plus Z. Okay, so now we have I'm going to rub all these things out. But just remember, the question is how many jets does she have? And we said that the jets are Z. So we need to work out what is Z. How many jets? This is a question. Always read the question. So now you might get quite shocked with this. You say, oh my God, we only worked with one equation, with one unknown, and maybe two equations with two unknowns. Now you've got three equations. Let me put all these things neatly here. X plus Y is 21. Y plus Z equals 23. And X plus Z equals 26. Okay, I'm just gonna written them neatly on this side. So how can I work out what X, Y, and Z are? When you have more than one equation, the idea is to eliminate one or more of those unknowns. That's one of the ways of doing it. So elimination means you try to get rid of it. And how do you get rid of it? There are ways, like for instance, now if I had 3x plus 5y equals 10 and 2x plus 3y equals 11 or something, then solve. Now you got two equations in two unknowns. So how would you solve this? So one of the ways of doing it is to make these coefficients the same. Now, how do you make the coefficient the same? This is 3 here. This is 2. How can you make them the same? Well, what you can do is, because you've got an equation, you can multiply right throughout the first equation by 2. Then I'll get y2, because I can multiply this by 2, I can get 6. And if I multiply this by 3, I can get 6. That way, I can get those numbers to be the same. But to get to a 6 here, you have to multiply this by 2, but you have to multiply everything by 2. When you got an equation, you can multiply the left-hand side and the right-hand side by the same number. So if you multiply this whole thing, this side by 2, this side by 2, this is what you get. And here, you multiply the whole thing by 3, and you get 6x plus 9y equals 33. Right? And then, now, once you got the same number, then you can say, I can subtract these two equations. I can take this part minus this part is 20 minus 33, because they are equal, you see. But when you take 6x minus 6x, it goes away. It's gone. The x has disappeared. And you take 10y minus 9y, right? That's y. and you got 20 minus 33 is minus 13. So there you have it. You have solved for y. So you can solve for y like that. And then if you want to find out what x is, then you put the y back inside here. So that you get rid of the y by replacing the y by its actual value. And then once you do that, then you have 3x plus a number equals a number, and you know how to solve that. So that is how we normally do it. In three equations, the same kind of a thing, but it's a little bit more complicated. Yeah, it's not so hard here because I can straight away, if you look at, I got a plus y and I got a minus y here, y here. So straight away I can subtract these two and the y's will disappear. So if I subtract these two, if you call this equation 1 and 2 and 3, if you subtract 1 minus 2, then you have x minus z. Because the y's disappear and you have x minus z equal 21 minus 23, which is minus 2. 21 minus 23 is 2. Now, we needed to calculate z. So, from these two equations, if you want to calculate z, you have to get rid of the x. But happily, the x can be immediately got rid of because I got x here, I got x. The numbers in front of them are the same. So immediately I can subtract these two. X minus x disappears, and you'll have z minus minus z. Watch out. And when you subtract these two, you get z minus minus z. So that's z plus z. So you get 2z, and you got 26 plus 2 is 28. Right? And then therefore z is 14. So that solves the problem. There are 14 jets. Okay. So it turns out that the three equations and three unknowns eliminate. I need to find out what z is. I've got an equation involving x and z only. So the idea is to try to get another equation involving x and z. And the way to do that is to subtract these two equations, because then the y's disappear and you have an equation involving only x and z. And then you got these two equations with only two unknowns. And then one of the unknowns that you're looking for can be solved. Okay. Now, that is one way of doing it, but there is another way of doing it, which is a clever way. I'm going to share that clever way with you. See, all these equations look the same. It's just a sum of two unknowns. In each of the cases, sum of two unknowns. So it's what you call this is like a symmetry in this. Now, when I look at the left-hand side, I've got two x's, I've got two y's, and I've got two z's, right? And if I add both sides, I can add equations. I can multiply equations. I can multiply an equation by a number, right? But you have to do it on both sides. So if you add on both sides, you'll have x plus x is 2x. Okay, let's finish. Then y plus y is 2y. Those two are gone. And z plus z is 2z. So we've taken care of all the symbols on this side. And now it's a sum of all these things. And when you work that out, you could see it is 70. So you got 2x plus 2y plus 2z is 70. And so, okay, let's divide right throughout by 2. You can do that. You can divide right throughout by the same number, which is the same as multiplying right throughout by half. So you halve every one of them. But it's easier to think of it as dividing this by 2. When you divide 2x by 2, it's really 2x over 2. And can cancel 2 times x, 2 times 1, that is x. So when you divide this by 2, you get x, so on. So now you got that, you see. And I want to work out what Z is. But you know what X plus Y is. X plus Y is 21. Because we got this very nice thing here. So you got 21 plus Z is 35. When you add, you got X plus Y plus Z, and you see an X plus Y featuring here. I need to work out Z. So then the question is, do I know what X plus Y is? Yes, it's there, staring at us. So you can replace the X plus Y by 21, in which case Z is equal to 35 minus 21. And once again, you get 14. See? So this is another way of solving this problem. So there are two ways of solving this problem, but this is a kind of a clever way where you don't have to solve for each one of them. You only need to, like this, you can work out everything very quickly, right? Because you know what Y plus Z is. So this is 23 here. So X is 35 minus 23. Straight away you got it. And X plus Z, you know what these two add up to. That's 26. So straight away you can get Y. So this is a beautiful way of actually solving for all three very quickly. Now, yeah, you can't do it like that. You might have to go back and substitute and do all kinds of things. This is a clever way. Sometimes you have other similar kinds of problems. Like for instance, I've seen problems like this, where it's not addition. You have xy equal to 10, yz, yz equals whatever, 15 or something, and xz is equal to something, 26, whatever. And they say, solve for x, y, and z. Right? Now, this is very similar to x plus y plus z, xz. And in that case, there we added every one of them. But here you got these things are being multiplied, xy, yz, and xz. So why not multiply every one of them? Because you got two x's, two y's, and two z's. But when you multiply them, you got xy times yz times xz. That is equal to 10 times 15 times 26. Now you got two x's, you see. You got x squared, two y's, y squared, z squared is equal to something. And then you can work out x, y, z, because this is a perfect square. It's just a square root of whatever you got on the other side. But once you got x, y, z, then you can calculate every one of them very quickly. Suppose x, y, z, it's not going to be this, but suppose it's about 13 or something like that. I'm not saying that this is 13. It's certainly definitely not 13. But just say it is that. Then you can work out x straight away. Because to work out x, you just observe that yz is known, it's 15. So x is equal to 13 over yz, which is 15. So straight away you got what x is. Like that, you can work out what y is, what is z is. So very quickly, you can work out those three unknowns, right, in this method, which is a very powerful method. It only appears in certain instances, but it's useful to know. Okay. So that takes us to problem number 5. Eve chooses some numbers from the set. Okay, so you got a set of numbers. 1, 2, 3, 4, 5, 6, 7. There. It's a set of numbers which have got eight numbers in it. But there's a kind of nice pattern amongst these numbers because each one is double the previous one. 2 times 1, 2 times 2, 2 times 4, 2 times 8, and so on. So each one is doubled. Okay, let's not worry about that for the moment. But Eve chooses some numbers from the set, and Ali or Ali takes the rest. All right, so Eve chooses some number. You don't know what Eve chooses. She could choose any of these numbers. All right, we have no idea what she chooses. Could be Eve could be, for instance, 16 and 64. For example, we don't know. She just chooses some number. And Ali takes the rest. So the remaining ones just yeah. I'm just taking this as an example. I'm not saying Eve takes this. I have no clue as to which numbers she takes, but I just want to analyze what's going on here. It's 1, 2, 4, 8. So 32 and 128 remain. Okay, so Eve takes those two, and Ellie takes those two. But it now says the total of Eve's numbers is 31 more than Ali's number. So when you add these, and if you add these, this is 31 more than that. And right now, it doesn't happen like that. We've got 128 here. Okay, so we don't know what these numbers are, but we have this information that Eve's numbers, when you add them up, you're going to get 31 plus Ali's numbers because she's 31 more. Okay. So now that's where algebra comes in. So you say, you don't know what the sum of Eve's numbers are. So you said, let X be equal to its sum. The problem is about the sum of Eve's numbers. And Y equal to the sum of Ali's numbers. I don't know how you say this name. Never come across this name before. So you're adding all the numbers of Eve and you're adding all the numbers of. So here, your X plus Y is equal to those two plus all these. And you'll see it's actually the whole lot. So X plus Y, because Eve is the sum of them and Ali is the rest. So X plus Y, you know, it's all these numbers. So when you add them up, I'm not going to waste time with that. The answer is 255. So you know what X plus Y is. Then you're also told that the total of Eve's numbers is 31 more. In other words, X is 31 more than Ali's numbers. So X is 31 plus Y. So the question is now, what is the total of Ali's numbers? So the question is, Ali's number, the sum of Ali's numbers is Y. So our problem is to find Y. That's the problem. Now I've got X plus Y. I got X is 31 plus Y. So I need to find what Y is. Right? All right, so, well, from here, why don't we just write down Y? We can work out what Y is straight away. Y is on this side. Take X to the other side. You have X minus 30, well, 31 to the other side. X minus 31. Now you got Y in terms of X. You say this Y is in terms of X because Y is equal to only X's on the other side. And that's very useful because I know what X is. Oh no, I don't know what X is, but I can put Y here. I can replace the Y by X. So I have X plus Actually, I don't have to do that. Sorry. Let me just go backtrack a little bit. And let's just analyze what we've got. We've got x plus y, and we got x. Yes, we got x plus y is equal to 255. And if you want, you can say x plus y is 255. And here I can put x minus y to bring to the y to the other side is 31. The reason I do that is now I have two equations in two unknowns. Like earlier on, I told you how to solve these problems. So now you need to work out what y is. Right? To do that, you must get rid of the x. So you subtract these two. X minus x, that goes away. Y minus y, we've seen something like this before. Let's remember, that's not 0. It's y. When you subtract, you got y minus minus. So it's y plus y. And when you subtract these, you got 224. So 2y is equal to this. So y is 12. Right. So you can solve. You got two equations in two unknowns, and you can solve. Because earlier on, I told you how to solve two equations, two unknowns. You put them up like this and get rid of one of them, but make sure you have the same number in front of what you want to get rid of. And you can create that, right, by multiplying, as we saw, by something and multiplying by something. Yeah, I didn't need to do that because the numbers were already there. These two numbers were the same. So I can get rid of the x. That's what I want to do, find y, by simply subtracting these two. And then you will have your y. Right? Now, there could have been another way in which you could have solved this problem. Right? I could have done it like this. And this is a very useful technique. When you got two equations and two unknowns, find one in terms of the other. Now, you see x, I can replace x by something which has only got y's in it. So if you replace the x here, the x is 31 plus y. So if you, in place of the x here, in place of the x, I put down 31 plus y. So still rewrite write that equation. You got 31 plus y equals 255. Now you got only one unknown, y plus y, 2y, 255. The number goes to the other side, and you'll end up with the same answer. So this is another way of solving this problem where you can find one of them in terms of the other. Very, very useful method. This is very powerful. Right? The elimination method is one way, but the other one is where you write one of the unknowns in terms of the other, and that gets rid of that unknown because you replace that x by something else, so that x is gone. Wherever you see that quantity, it's gone because you're replacing it, and that eliminates, gets rid of that unknown, and that helps you a great deal because then you are simplifying the problem. The one unknown is gone, so you've got fewer unknowns to work out. That's a very useful strategy. It happens very often in these problems where you do this. So in what we are doing here, we're working on a lot of equations and we're solving equations. Right? I know that some of you are in grade 8, some of you in grade 9, maybe there are some grade 7 as well. And you're going to come across a lot of equations in your school career. And these will be discussed from time to time in your classroom, exactly what I am doing here. And they will just give you some techniques in solving, equations with one unknown, two unknowns. You don't ever do three unknowns in school, although I can't see why you shouldn't. But we have actually seen that problem where you have three unknowns earlier on, the jets, the cars, and the teddy bears. So you can have that. But even if you have more unknowns, you don't have to be too afraid of them because there are ways of actually solving those equations. And that is one of the techniques is to replace unknowns by other quantities. Each time you got a replacement for an unknown, substitute it and it's gone. See? But keep record of what the solutions are. Okay. I think maybe the next problem might deal with that. So the answer to this problem here is 112. Without even knowing what the actual numbers are, we can work out what Ellie's numbers, what the sum is. All right, now problem 6. Now it's getting a little bit more challenging now. In a class test, each learner scored 1, 4, 5, or 8 points. So the number of learners who scored 4 points is the same as the number who scored 5. The total number of points scored by the class is 63 more than the number of learners in the class. Now this is quite a mouthful. But the thing is, it's the number of learners who scored 4 points or the number of learners who scored 5. We don't know what these numbers are. So let's give names to that. The starting point is let's give names to these. There are 4 types of students. A equals the number of learners scoring 1. B, we'll give symbols to that. Number of learners scoring 4. So like that, we call them A, B, C, D. So you got 1, 4, 5, and 8. A, B, C, D in that order. Okay, now let's see what's given. The number of learners who scored 4 points. Now, the number of learners who scored 4 points is B. Let's translate this part here. The number of learners who scored 4 points, what do they say about it? Is the same. So it's equal to the number of learners who scored 5. So the number who scored 5 is C. So you got B equals C. So straight away, you got B is in terms of C. So I can get rid of the B. Or if you want, you can get rid of the C because you can replace the C's by B's. Or you can replace the B's by C's, wherever you have equations. Okay, now let's just look at that. Now, the total number of points scored by the class, right, what's the total number of points scored by the class? Now, that requires a little bit of calculation. A of them scored 1s. So all those scored 1s, the total of the 1s is A times 1. So that's A times 1. I'm going to calculate the total number of points. So the 1s, the total points there was A, and B, the total number of points contributed by B, each one contributed 4 points. So that's 4 times B, or 4 times B. And then C is 5 times C. That's the number of points contributed by C. And those who scored 8, each one scored 8. So D of them scored 8 times D. So the total number of points altogether, there, they say it is 63 more. In other words, it's 63 plus what? 63 more than the number of learners in the class. Okay, now these are the learners. The number of learners who scored 1, number of learners scoring 4, and so on. So the number of learners is just A plus B plus C plus D. I put it here. 63 plus A plus B plus C plus D. This is the number of learners in the class altogether. So if you were to write this thing down properly, you'll start off by saying total marks scored. Sorry. Total marks scored. And then you'll work this out. It's A plus 4B plus 5C plus 8D, right? And this one here will be the total number of learners. Is A plus B plus C plus D. And then you will write down this equation. This minus this is 63. If you want to say that, I think that might be better because this is 63 more than the number of learners. So when you subtract these two, you're going to get 63. So let's subtract these two. A minus A is 0. 4B minus B is 3B. 5C minus C is 4C. 5C minus C. 8D minus D is 7D. When you subtract these two, right? And that is equal to 63. See. All right, so when you calculate these quantities, you'll see and take into account what is given, you'll see that this is 63 more than that. So when you subtract, you get 63. If you wanted to write it down like this too, that's okay. But then you'll have to take this and put it on the other side and you get 63, which is exactly what I've done here. All right. So you have this equation here now. You have this equation, 3B plus 4C plus 7D is equal to 63. Now, look, I'm just taking all the information and I'm just writing it down. B equals C. So in place of B, I can put C. So you have B is equal to C. So in place of B, I can put C. So you've got 3C plus 4C, because B equals C, plus 7D equals 63. All right. So you notice that A is gone, B is gone. We only got C and D left. And this is 3C plus 4C is 7C, plus 7D is 63. Ah, we got 7's right through it. Can't leave it like that. So let's divide right through it by 7. Because C plus D equals 9. All right. So I've just taken down all the information and I've recorded them, right? And eventually, using the information, I come to this conclusion. The C plus D equals 9. Right. Actually, I should have looked at the question first. It was naughty of me. But let me just have a look at this. How many learners scored 5 or more points? Okay. So in other words, how many learners scored 5 or more points? It's only these learners here. Now, these guys, they didn't score 5 or more. This scored 5, and this is more than 5. So the total number of learners who scored 5 or more points is C plus D. It's not 5 plus 8. Watch out. This is the number of learners who scored 5. But here, the number of learners is C plus D. So the question is, what is C plus D? That is really the question. How many learners scored 5? And lo and behold, we've already solved the problem. C plus D is 9. Without knowing what C and D are, the question is such. It doesn't ask you what is C. It doesn't ask you what is how many people scored 4 points or what. It doesn't ask you all that. The question is, how many learners scored 5 or more points? So you really need to answer this question. Right. Okay, so let's get on to the next problem. Now, let me just say, give you an aside here. What I was, one, and a very, very important thing, I said this last week, and I say this again. Before you come to this class, you have the problem set. You must go to that problem set before you attend this class. You say, we're going to do session 2 on Thursday. So during the weekend, Monday, Tuesday, you should be looking at the problems on session 2 and trying them out, so that when you come here and you get the answers, it'll be very meaningful for you. You'll say, now I know how to do it. I struggled with this one, but now the prof is giving me the answers, and it's such a nice answer. You will appreciate it. But if you don't tackle it, it's just a waste of time. If you haven't tackled the problems, don't waste your time coming to this class. Because what's the point of knowing the answers even before you know the questions? You don't do mathematics like that. So you must try it. Doesn't matter if you fail, but you must try it and get an understanding of what the question is, and then come to the class. Right. And for that reason, normally I would go a little bit faster in these programs, because I would have assumed that you have already looked at these problems. All right. Now, the number 16 is placed in the top left corner of a 4x4 table. I'm going to do that straight away. There's your 4x4 table. Top left corner is 16. Right. The remaining 15 squares, don't worry about the shaded part, but there are 16 squares altogether. 4, 4, 4, 4. So the remaining 15 squares are to be filled using each of the numbers 1 to 15 once only. So you got 1, 2, 3, 4, 5. They're scattered all over the place. Okay, so you don't know where these numbers are. But so that the sum of the 4 numbers in each row, so in each row, the sum of the numbers, let's call this number x, this is a row. Each column, O. So even this way is x. All right, the sum of the numbers in each row, each column, and each main diagonal. The diagonals are this one here. Main diagonal are these two. These are also diagonals, but it's a small diagonal. It's not the main diagonal. The main diagonal goes right through this thing. They're all the same. So in other words, when I add up all this, I'm going to get x. When I add these, I'm going to get x. Add these, I'm going to get x. Add these, I'm going to get x. And likewise, when you add all these, you're going to get x. This way, this way, this way. Okay. So now the question is, what is the sum of the 6 numbers in the shaded square? We have no idea where these numbers are. And it looks as if this problem is impossible to solve. But you will see just now that if you systematically go through the information, there's a lot of information given here. Now, the fact that each of those 4 numbers add up to x means I can add up all the numbers, the sum of all 16 numbers. Is equal to x plus x plus x plus x, which is 4x. X is that common sum. All these add up to x, and the diagonals also add up to x. But we know the sum of all the 16 numbers, because it's all the numbers from 1 to 16. I'm not going to write all this, it's too long. All right, now you can add up all of these numbers. Right? It takes a certain amount of time, but it's possible. It would have been impossible if you had 1 plus 2 plus 3 all the way up to 500. Okay, But is it impossible? Actually, even that is possible. The reason being, this kind of thing here, there's a very clever way of calculating what the sum is. The clever way is that this particular one, this strategy is only used in certain cases. Don't try to use it in all cases. In this particular one, I'm going to tell you just now, in which cases you use them. This particular one, you can try, you say the sum here is this, but you can write it backwards. It doesn't matter whether you're writing it forwards or backwards. This dot, dot, dot means I'm not writing out all those things. I don't have the patience to do that. I just know what they are. Now, why? What is the point of writing it backwards? The sum remains the same. Now I'm going to add on both sides. So 4x plus 4x is 8x. 1 plus 16, 17. 2 plus 15, 17. 3 plus 14, 17. Now this is beautiful. 4 plus 13, 17. And even you go right to the end there, you get 17. So it is 17 added to itself a number of times. Now that is easy. Because when you add 17 to itself, how many times? 16 times. You get 17 times, 16 times. 16 17s you've got here. 16 17s. So 8 times x is 16 times. So x is 16 times 17 divided by 8. 8 multiplied by that gives you this. Now, as I told you earlier on, this kind of a thing is very easy to calculate. You don't have to multiply 16 times 17. You just cancel. 8 goes in 16 2 times. 2 times 17 is 34. And lo and behold, we've actually found x to be 34. Now, the reason why this worked is because all these numbers became the same here. Right? When you added the two, you're going to get exactly the same numbers right throughout, and that is very easy to calculate. And that happens in this case, but it can also happen in other cases. Right? I want you to go and check to see which cases it'll work, this method. Right? Try to investigate it and try to come up with some idea. So when will this work? When you add, what kind of numbers must you have here which you're adding? Right? I can give you a little clue. I can tell you, like, for instance, when you're adding 1, 4, 7, 10, 13, and so on, right? It works for that also. That's a clue. Because in that case, again, you say that the sum is the same thing written backwards. Okay, so now you know the sum, these 4 numbers is 34. So we can now work out the sum of all the white ones. I'm going to work out that one. That's 18, because 16 plus 18 is 34. And these white ones here, the columns also add up to 34. There's 16 here, so these add up to 18 as well. These 3. And it's given that even the diagonals add up to 34. So you got 16, and those 3 also add up to 18. So the unshaded numbers, which are the white squares, we know what the sum is, because we've got the sums written in all those cases. So the unshaded numbers is 16 plus 18 plus 18 plus 18. There are 3 18s there. 18 along the diagonal, 18 along the row, and 18 along the column. So the unshaded part is 16 plus 3 18s, which is 70. Right, but the question is, what is the sum of the shaded parts? Right? Okay, we don't know what the shaded part is. But we do know that the shaded part plus the unshaded part is a sum of all of them, is equal to sum of all the numbers. But that'll take care of the whole 16. And that is 34 times 4, because that's 4x. And the sum of all the numbers is 4x, so it's 4 times 34. Which is 136. So we know what this is. This is 70. We know what the total is. That's 136. So that allows you to calculate what the shaded part is. Should be 136 minus 70. So that's the answer to that question. Okay? If you think about it, it's not so difficult. The important thing is that the starting point is very important. Let x be the common sum. You must know what x is. Understand it perfectly. It's a common sum. Because it says that all the rows and all the columns and all the diagonals add up to the same thing. So you can give a name to it, and we're calling it x. Just to start this thing off, to say what x is, you will be given a point. If you don't say what x is, you can lose points, because the person who's reading it must know what you are talking about. What do you mean by x? So it's extremely important. That is why you use the word let. Let immediately tells you are giving a name to something. Okay? So that takes care of that. I'm going to just skip this particular problem because it'll take a long time to do this. We'll come back to this. Problem 9 we'll come back to. Okay, let's look at problem number 10. It says that an s by s square, where s is an odd integer, is divided into 1 by 1 unit squares. Now, when you have a problem like this, you say, hey, what is s? Now, it's such a, you don't know what it is some abstract thing, and you just get turned off. So it's nice to just put a value to s. Say, suppose you say it's a 5 by 5 square s. Suppose s is equal to 5. You want it to be an odd number. Don't make it too small, 1 or 3 or something. 5 seems to be a reasonable number. Okay, so I'm going to take a 5 by 5 square. Okay, so 5 rows. Sorry, I should have used my nice straight lines here. And I could have just gone this way like this. 5 by 5. Okay, suppose now s is equal to 5, so this is the story you've got. Now, all the unit squares along the edges and the 2 diagonals are removed. So the edges are these. So let's just, these are the edges, and these are removed. Okay, so how many have you removed here now? 5, 10, 16. So 16 have been removed. So what is left? It's 25. The question is divided into this. All the unit squares along the edges and the 2 diagonals are removed. So that's, I jumped this part here. So the edges are removed, and the question is find the number of squares remaining. So let's see how many squares are remaining here. We had originally had 25. You removed 16, so you have 9. And you can see what the 9 squares are. And that's the one I've got here in the middle, right? So you've got, these are the remaining squares. But wait a minute, even the two diagonals are removed. So even these are removed. Let's just put them like this. That's one diagonal, and there's another diagonal, right? So 9, and so it's really not 25 minus 16. You have to add these remaining 5 here. So it's another 5 are removed, right? So it's 9 minus 5, which is 4. So the only ones which actually remain in this problem here are these. So the answer is 4. If S is equal to 5, the answer is 4. Right. Now let's see now what happens when you don't know S is equal to 5. Okay. So if you remember, we said that what remains is 25 minus 16. So it's actually yeah. So in the 16 is actually yeah. So we are counting all the yellow ones. Those are the ones which are removed. Okay. And what is left? What is left here is just the red part. Right. So it's actually, we had so the red part is removed. So you have, like how we had 9 here, the 9 is really 3 squared. Right? So when you remove all the edges here, what remains here is a 3 by 3 square. And from 5 we came down to 3 because we are taking out that and taking out that. So if you had S here, you'll have S minus 2. So this is where the 9 that we had was S minus 2 all squared. That is your 5 minus 2 all squared. Then we said, but wait a minute, we also removed these diagonals, right? So we have to subtract again this number here, and we saw that this is 3, which is S minus 2, and you have to subtract the other one, so that twice that, this plus this, I have to take them out. But you notice that this one here is counted twice. So when you count this, you count that, you overlapping this thing. So you counted this twice, you have to put that back in. See. So it's actually 9 minus 6. If you put this, 9 minus 6, but we actually had 5 here. Why? Because you counted this twice, so you only count 1, 1, 2, 3, 4, and you must avoid that because you already counted it, 5. So you have to put that back in. So this is the number that you have when you have S minus 2 all squared. If you look at this, you will see it's really S minus 2. You see, when you have something like x squared, this is x squared minus 2x plus 1. if x is equal to s minus 2. Now, this is a very familiar number, hopefully. X squared minus 2x plus 1 is really x minus 1 all squared. Right? And x is s minus 2. So your answer is x minus 1, which is s minus 2 minus 1 all squared. Right? You can expand this thing here, and you come to the same thing. There you get, but you have to factorize the thing at the end. But notice it's a square. So this is a perfect square. Okay. So the question is, find the number of squares if s is 103. That's a very nice number because 103 minus 3 is 100. And you don't have to use a calculator to work out 100 squared. 100 squared is 100 times 100. It's 10,000. So I'm illustrating it by a small case, trying to find out exactly what is being left out and then generalize it to where you don't know what the number is. And that's a little bit tricky. So hopefully you will listen again to this video, which will be on the webpage, and try to understand where this thing here came from. This part here. Right. I don't have time to do the other one. I thought I will have time, but I spent quite a lot of time explaining some important things. So that's okay. So number 9, I'm going to carry over to next week, or number 10 or whatever. Let x1 be real, and for every integer n greater or equal to 1, because this looks really like gibberish. What the heck is going on here now? For every integer n greater or equal to 1, you got this kind of a thing. So let's try to unpack the mystery of this by giving a value to n greater or equal to 1. So let's put n equals 1 and see what happens. To understand what this thing here is. So n equals 1, substitute exactly for n equals 1, and you have 1 plus 1 at the bottom. 1 plus 1 is 2. Then you have 1 plus x1. But now you got a product of a lot of things here. X1, x2. But it's ending up at n. So n is 1 here. So you have to end right here at 1. You can't go any further than that. Okay, let's try n equals 2 and see what that is saying. When n equals 2, then you have 2 plus 1 at the bottom. So that's 2 plus 1 is 3. And you have 1 plus. Now you have to go up to n equals 2. So this time you're multiplying x1, x2, and you stop dead here because you can only finish off at n. So x3 is this one. So likewise, if you try x4, you have to finish off at 3. And so on. And they tell you what x5 is. So x5 is 1 plus x1 plus x2, x2, x3. You have to finish at 4. But you are told what this is. This is 43. This is 43. So you are given what this is. So this is 43. You got all these horrible looking unknowns here. But let's not worry too much about that. Now you got another more complicated thing. Find the highest prime factor of x6. And that will really put most people off. They say, no, we don't know how to do this. But if you are a dogged student, if you're persistent, you say, first let me find what x is, x6 is before I throw up my hands in despair. It's x1, and it ends up at 5. Now, what is the highest prime factor of this? It looks as only God knows. But when you look at this thing carefully, you say, but wait a minute. I've got x1, 2, x1, x2, x3, x4. I can calculate that. x1, x2, x3, x4 is actually 43 minus 1. So this part here, that product is 42. That's very nice. In one breath, 4 guys have been killed. But now x5 remains. But wait a minute, x5, you were told x5 is 43. So that's not a big mystery. So you're multiplying these two. 42 times 43. And you have exactly what x6 is. You know what it is. It's 1 plus 42 times 43. Now you need to know what the highest prime factor of this is. So you have to calculate this wretched thing, right? Fortunately, it's only two digits by 2 digits. When you calculate it, you get 1,807. And you have to work out the highest prime factor of this. Now that is it's a problem. And you have to try all the factors, 1, 2, only the prime factors you have to try. Obviously, 2 you can discard. 3 you can discard as well because they add up to 16. 4 and 5. Next one is 7. You can try 7. 7 doesn't work. 11, when you try 11, 11 doesn't work too. And you say, oh my God, now it's going too far. But fortunately, at the next place, 13, it works. Because when you work this thing out, you'll see it's 13 times 139. Right. And 139, you'll have to see whether any factors go into that, but it turns out that this is a prime number. So the highest prime factor of x6 is 139. That's the answer. This is a good example of something where you think it's almost impossible to solve, but if you just keep your cool, take a deep breath, and do it step by step, you'll eventually solve this. But be cool, right? Don't run away. And then you will see as you go along certain things, your eyes start opening to certain observations. And then if you prod along, you'll come to the answer. Okay, so that brings us to 6:34 according to my clock. And I don't have anybody in the chat column who's asked me any questions. So there are no questions in the chat column. I missed out one question because that will take a long time to work out. And I'm not sure whether I will do it next week. But you can try it. That's number 10. Right? It's a rather difficult problem. In fact, maybe I should not have given it to the juniors. So, but if you can try it, that's fine. If you can't, that's also fine because it's a little bit difficult problem. Okay, but please go over the problem that I've done and try to do it on your own now. Right? Try to do it on your own and see how far you can go. And only when you can't do it, go and listen to the recorded lesson and fast forward to the particular point where you want to get to and see what I have done is, oh yeah, wait a minute. I remember you said this, and then go back to your problem and try to solve it. Don't read the entire solution. Most of the time you must try to do it yourself. But now that you've already done it, you must go over it again because there are lots of interesting techniques here which will help you to solve other problems. So do it again a couple of times until you're quite familiar with the solution to each problem. Do this for all these 9 sessions, and I can assure you that if you read for all 9 sessions, you'll go straight into round 3 next year. Maybe the top 10 as well. Okay. So, but you must be diligent. That's your work. You got homework to do. Please hand that in. Thank you for those people who have already handed in homework to assignment 1. And many of you have done that. That's very good. Now, that is the past now, but you must do homework 2 onwards for the other people. And go to this website, which I told you right in the beginning. Right? Some people might not have been here. I'm going to write it down again. The website for the South African Maths Foundation is www.samf.org. South African Maths Foundation. And it's AC, not CO or anything, but it finishes off with ZA. AC, all universities and high institutions got AC.ZA. Go to that, and the rest you can just navigate through that and go into this Siyanqoba training program, and you will see a lot of information there, and you'll find your assignment question for the session 2 somewhere there, the page. Pull that out, solve the problem in the assignment, and send it back. It's all very, very easy because you can do it online. You don't have to do anything else. Isolate that. And anyway, you'll get information regarding that in your email about how to get assignment problem. Go and do that. If you get stuck with it, ask somebody to help you. But I'm sure you guys, all computer fundies, only I struggle with all these things. Okay, I hope you will do your assignment, and thank you very much for listening, and enjoy the rest of the weekend. Oh, it's not weekend. Where are we? Thursday. Okay. So do your assignment and do session 3, the problem of session 3 as well. Try them out, and also the remaining problems in session 2. Keep yourself busy if you want to do well in mathematics. Okay. All right. Goodbye.